Okay, this is day B of stretches and shrinks. So let's just talk through a few of the type of problems that you're going to need to know for today. We're off at a little conference, and if you're listening to this video, that means that I'm going to try to teach you instead of your reserve teacher today, because we know exactly how we want this taught. Number one, A. So if I'm going to start a problem like this, for instance, I would want to look on the inside and see what was done. That was a divide by 2. I would like it better if that was written this way. Y equals square root of 1/2 x. Now you guys know what the square root one looks like, right? It looks kind of like this. And now this one is going to be 1/2 as wide. No, it's not. Remember, the stuff on the inside is not to be believed. So it's not half as wide, it is twice as wide. So I'm going to take all those parent points, which would be here and here and here, and then over 9 up 3, those parent points, and I'm going to make them be twice as wide as they used to be. So, for instance, 0, 0 doesn't move at all. But 1, 1, twice as wide means I got to move it over to 2. Notice I didn't change its height, I just moved it over 1. This, the one that was at 4, that point needs to be right here. That guy needs to be moved over twice as far also, which means over to 8. So there we go. And basically this black one is your answer. It's been stretched twice as wide. Now if you want to do that with an XY chart, you make an XY chart like this, and you take the original parent points, which were at 1, 1, 0, 0, let's see, 4, 2, and I would do this 1/2 right here to all of the x numbers. But remember, it's counterintuitive, so you don't do the half, you do it times 2. So I times these all by 2, and then 1 times 2 is 2, and 0 times 2 is 0, and 4 times 2 is 8. So then I'd graph those new points. 2, 1, and 0, 0 stays the same, and 8, 2. That's another way you can do it. Okay, so if you like the XY chart way, awesome. If you don't, if you just want to move it and slide it and flip it, that's okay too. This one here shows us a whole different kind of problem. We have to start by multiplying both sides by 3, because we really don't want this stuff on the left side. So I'm going to multiply both sides by 3, and that 3 goes away, and then I have a times 3 in the front. So now it's y plus 6 equals 3 times x minus 2 squared. Then I get that 6 off of there by subtracting 6. I'm going to put a minus 6 at the end here. Minus 6. Now I can see it's a parabola that's been moved to the right. And then it's stretched 3 times taller, and then I'm going to move it down 6. You can do that with an XY chart if you want to, by taking those parent points of a parabola and then doing each of those things to it. All right, let's move down to later in the worksheet. It says, solve each equation for y, and then describe the transformations. Notice it says to solve first. So I recommend that when you're solving these, that you just, say, multiply by 2 on both sides. Just write them out the way you would normally see it, like this. In fact, you might even want to be smart and go 1/4 in front of it like this. That's easier to read. 1/4 x. And then you'll say, oh, so this means 4 times wider, or horizontal stretch with a factor of 4, and this would mean a vertical stretch with a factor of 2. All right, moving down to other types of questions that you would have. Let me clear off the ink here. In this type of question, it's write an equation for each transformed function. So for instance, let's say I was doing this one. Y equals absolute value of x is shrunk vertically by a factor of 3. Y equals, and I have the absolute value of x. If I'm going to shrink it vertically, that means that the vertical stuff happens on the outside. So if I'm going to have a factor of 3, I'm going to put a 3 here. But wait a minute. If I shrink it vertically by a factor of 3, then shrinking by a factor of 3 would really mean I'd need to do 1/3 in the front. Then reflected over the x-axis. Okay, reflected over the x-axis. Let me think for a second. The x-axis is this one. So that's an up-down kind of a flip. That should be a negative in the front. and then translated down 1, minus 1 at the end, and right 2, minus 2 in there. Okay, just trying to coach you through the types of problems you might encounter today. And let's look at this one. And what's the description of the changes that happened here? Well, if you think about it, this graph used to be right here, basically, and now it's been moved, looks like it's been moved 2 to the right and up 1. Okay, so I'll factor that into my answer in my description. And it also looks to me like instead of going over 1 and up 1 like you normally do on a parabola, this one has been stretched. And it looks like it is 3 times taller than it used to be. I go over 1, and instead of going up 1, I'm going up 3. So it looks to me like it's 3 times taller. Y equals 3 times a normal parabola. And then it's also been moved to the right 2. Compared to the origin here, it's been moved right 2, so that's minus 2. Squared to show it's a parabola. And then it goes up 1, plus 1. All right, there would be a typical equation. The description is just describe the transformations. That's saying all these things, which is that it's vertical stretch of factor 3, and it's right 2, and my Parker's so thick it's hard to write. Right 2, and then up 1. All right, so there are descriptions that you would write in of how this thing has moved. All right, that's all I've got for you. I just wanted to keep this a quick explanation on how to work on today's homework. Let me see if there's one more kind of problem on here. Those are basically the same. Oh, this kind is tricky. Let me help you with number 5. X is replaced with x over 3. What they're really trying to say here is what's the difference between x and, again, I like to write this as 1/3 x. What's the difference between those two? What happens to the graph? Well, if I replace the x with, that means I was on the inside. Do you get that it has to be on the inside if you're replacing an x? Like if this had been an x squared, it's like imaginary parentheses around this. So if I replace this with that 1/3 is on the inside. So if I replaced x with x over 3, it's basically like this, and now it's a 1/3 on the inside, so it's not 1/3 as wide, it's 3 times wider. But the official name for that is a horizontal, it's on the inside, so it's horizontally on the inside, so it's horizontal stretch factor of 3. Okay, that's all I got for you for real this time. Take care.